Okay, we're continuing probability today. I think today is pretty tough. Do your best. Please email me if you have questions. Listen to the video multiple times if you need to. I'm going to try to go quick, but try to be thorough as well. We're talking about conditional probability today, and we're also talking about tables today. First off, a conditional probability contains a condition that sort of limits the sample space for an event. It's written like this, so the probability B sort of slash A. And what it's saying is find the probability of event B given event A. So if event A has occurred, what is the probability of getting sort of this event B? The easy way to do this is just to basically think of this as a fraction sort of inside here. So if you think of the slash as almost like a fraction, however many represent B and however many represent A, you just put the given amount, so event A, on the bottom, and the thing that you're looking for on top. So what I mean by that is we're going to take all the things that represent B and put that over all the things that represent A. And that's going to be sort of the shortcut we're going to use. If you can think of it like that, this is not going to be that bad. If you try to think about it too much, I think you're going to screw this up. All right, so let's look at this first example. The frequencies of the marbles in a bag are shown below. Write your answers as reduced fractions. We're not going to reduce the fractions. We just want to write the basic fraction that we get for our answer. So before we even get to this new thing, we need to talk about tables. Specifically, if they don't fill out the tables for you. What this table is saying is that we have large marbles and we have small marbles, and there are 2 green large marbles, there are 4 blue large marbles, there are 8 green small marbles, and there are 12 blue small marbles. We want to go ahead and fill in these totals. We're not going to use all these numbers, but it's a good idea to go ahead and fill in everything first. So our total amount of large marbles are going to be 2 plus 4, which is 6. Our total amount of small marbles is going to be 8 plus 12, which is 20. Our total amount of green marbles, both large and small, is going to be 2 plus 8, which is 10. And our total amount of blue marbles is going to be 4 plus 12 is 16. What is our total amount of marbles, total? You can either add these together or you can add these together. We should get the same thing either way if we did this correctly. This is sort of the way you can check your answer at the end. 6 plus 20 is 26, or if we did 10 plus 16, that's also 26. Okay, so the first question is not a conditional probability at all. It's just asking you basically what is the probability of pulling a small marble out of the bag. Well, there are 20 small marbles, and there are 26 marbles total, so we're just going to say we have a 20 out of 26 chance of pulling a small marble. So this is kind of what we were doing back before spring break. The second question uses this new conditional probability. Basically what it's saying is, given that we choose a large marble, what is the probability that it's green? That sounds confusing, but if you just think about it as taking your green marbles that are large and putting it over your large marbles, well, what I mean by that is this. We have 6 large marbles. So the second thing is what's always going to go on the bottom. So what are the chances that we drew a green marble if we drew a large marble? Put whatever the second part is here, that's the number that goes on the bottom. There are 6 large marbles total. How many of those large marbles are green? Well, 2 are green. So we have a 2 out of 6 chance of pulling a marble that is green if we had pulled a large marble. That sounds confusing. We're going to do a few more of these. We are going to come back to this example. Go ahead and flip over, and I want to look at a few more that have it nicely written out for us. So we're going to go to number 5 and number 6 next. The table shows the results of a poll of randomly selected high school students who were asked if they prefer to hear all the school announcements in the morning or the afternoon. Write your answers as reduced fractions. Again, we're not going to reduce the fractions. Let's just write out the fraction. we need to fill in the table first. So again, do this thing. You know, who prefers to hear morning announcements? There were 8 underclassmen and 14 upperclassmen that prefer to hear that. So total, 8 plus 14 is 22. For the afternoon, there were 18 underclassmen and 10 upperclassmen, so that's 28 if I add those two numbers together. My total amount of underclassmen in the survey is 8 plus 18, that's going to be 26. And my total amount of upperclassmen in the survey, 14 plus 10 is 24. To find your total amount of sort of everybody, either add these two numbers together or these two together, and you should get the same thing regardless. 26 plus 24 is 50. 22 plus 28 is also 50. Okay. So, if I ask you to find the probability of the person preferring morning announcements if that person is an underclassman, take the second part, and that needs to be the number on the bottom. So how many underclassmen did we have total? We had 26 underclassmen. So if the person was an underclassman, what were the chances that they preferred to hear the announcements in the morning? Well, 8 of those underclassmen out of the 26 preferred to hear it in the morning. That's it. That's your answer. So there's an 8 out of 26 chance that if you choose an underclassman, they're going to prefer to hear the announcements in the morning. So number 6, okay. Find the probability that the person prefers to hear them in the afternoon if that person is an upperclassman. So take the second part. How many upperclassmen do we have? We have 24 upperclassmen. And what are the chances that an upperclassman prefers to hear the announcements in the afternoon? Well, 10 of those upperclassmen preferred to hear the announcements in the afternoon. So there's a 10 out of 24 chance that the upperclassman is going to want to hear it in the afternoon. We're not going to worry about reducing these fractions. We're just writing out the fractions. Well, let's keep going. This one down at the bottom. The table shows the results of a customer satisfaction survey for a cellular service. And, okay, we need to fill in the table. I guess I should keep reading the question. In the survey, customers were asked whether they prefer a plan with a provider to a friend. And it looks like we have different cities that are sort of answering this question. We're still going to fill in the table the same way. Don't let the fact that the table has more parts than the last few mess you up. You're still doing the same thing. So add up all the numbers for our yeses to find our total amount of yeses. 40 plus 35 plus 41. You're probably going to want to use a calculator. I'm just going to tell you that's 116. 18 plus 10 plus 6, that's going to be 34, so that's our total amount of no's. The total amount of people answering this question in Arlington is going to be 40 plus 18, which is 58. The total amount of people answering this question in Towson is going to be 45. And the total amount of people answering this question in Parkville is going to be 47. For your total, this sort of last box, you can either add these two numbers together or these three numbers together. Either way, you should get 150. Okay, so this first question is not a conditional probability question. It just wants to know what is the probability of choosing somebody that said yes. Okay, well, how many people total said yes? 116 people said yes. Out of how many people total? There was 150 people total. So you have a 116 out of 150 chance of choosing somebody that said yes. The second question, this is a conditional probability question. If we chose somebody randomly from Arlington, what is the probability that they said yes? So take that second part. Take sort of that number that goes with Arlington. There were 58 people in Arlington. That goes on the bottom. How many people said yes in Arlington? Well, there were 40 people in Arlington that said yes. That's our fraction for that one. Are these two probabilities the same? They're not. I mean, we didn't reduce them, so I guess it makes this question a little harder to do. But even if you reduce these fractions, they would not be the same. The total amount of people, the probability that somebody said yes overall is most likely not going to be the same probability as somebody saying yes from Arlington. And we didn't need to do this to sort of answer that question. We should understand that just from sort of thinking about it. No. Go ahead and try this one here at the bottom on your own, you might want to hit pause and just sort of see what you can do. I'm going to go ahead and work this out now. So I'm assuming you hit pause and worked it out. I want to, we're talking about Roberto at a car dealership, and he's looking at his workers to see how good a job they're doing. Fill in your totals first. Becky, there were 12 total successful and unsuccessful. Raul had 9. 6 plus 9 for Daryl is 15. For the total amount of successful car sales, we had 16 total successful car sales, and then it looks like 20 unsuccessful car sales. To find your total over here, either add these two numbers together or these three numbers together, and either way you should get 36. Okay, so now for the conditional probability part. What is the probability that if we're looking at Becky, she made a successful sale? So look at all the total Becky, interactions with customers. She had 12 interactions. And how often was she successful? She was successful 6 times out of the 12. So what is the probability that if we're looking at Daryl, he had an unsuccessful sale? So take your Daryl number. Daryl had 15 total interactions with customers. How often was he unsuccessful? He was unsuccessful 9 times out of that 15. Okay. If you flip back to the front, we're going to do that example that was on the front that I had to sort of skip over. And hopefully we'll see why I had to skip it. It's just a little more confusing. It's not written in the nice way where it says probability this/this. We got a town planning committee considering a new system for public transit. Residents of the town were randomly selected to answer 2 questions. Do you work less than 5 miles from home? Would you use the new system to get to work if it were available? And the results are shown below. Before we get to the questions, let's go ahead and fill in our table. How many people said yes to using the new system? 24 plus 32 is 56 people said yes. And for no, 44 plus 20, we had 64 people say no. They would not use the new system. How many people work less than 5 miles from home? 24 plus 44 said yes, they work less than 5 miles from home. 24 plus 44 is 68. And 32 plus 20 people said no, they do not work less than 5 miles from home. So that's 52 there. So our total, we would either want to add up 56 and 64 or 68 and 52. Either way, you're going to get 120. Okay, so these 2 questions, they're not written nicely for us. We have to really think about what it's asking us to do. If the residents work less than 5 miles from home, what is the probability that they would use the new system? So basically, given that they work less than 5 miles from home, what is the probability of the new system? So what that is this. The given part is that second part of this sort of conditional probability. And then the part it's asking us to find is what goes first. So I'm going to write this out using some words. So find the probability that they use the new system. So use new system. I'm going to do slash that they work less than 5 miles from home. So if you're able to sort of write it out and think about what it's asking you, now we can do it the same way we did the other ones. How many people work less than 5 miles from home, or said yes to working less than 5 miles from home? So that's this yes right here. Again, this is another part that makes this question confusing. There are 2 yeses. We're looking at the one that works less than 5 miles from home. There were 68 people total that work less than 5 miles from home. So this is going over 68. So if the person does work less than 5 miles from home, what is the probability that they want to use the new system? So how many people said yes, they like to use the new system for the people that are working less than 5 miles from home? There were 24 people that said yes that worked less than 5 miles from home. So 24 over 68. That's our probability that a resident would want to use the new system if they work less than 5 miles from home. So number 4. What is, if residents are willing to use the new system, what is the probability that they don't work less than 5 miles from home? Okay, so this if part, this is sort of the given. Given that they want to use the new system, what is the probability that they don't work less than 5 miles from home? So we're going to say this. The probability that they don't work less than 5 miles from home, so not 5 miles from home, given that they wanted to use the new system. So how many people were okay using the new system? There were, this is this yes right here. There were 56 people total that said yes, they would use the new system. So it's going to go over 56. And what is the chances that out of the people that wanted to use the new system that they did not work 5 miles from home? That was 32 out of 56. Okay. That ends the notes. I know these notes were tough. Make sure you do the classwork tomorrow that sort of goes with this, and look at the video for tomorrow if you are struggling with the classwork. Have a good day. Don't forget to go on and do your digital learning evidence quiz thingy, mabobber.